So the Pythagorean triples says here 3, 4, 5, 5, 12, 13. Complete this one. AB 53. All right. So the only way we could possibly do this would be to have two numbers. Remember, we got a squared plus b squared, which was equal to 53 squared. Because this is like 9 plus 16 equals 25. 25 plus 144 equals 169. So this is a squared plus b squared equals to 53 squared. Pythagorean triples. What is 53 squared going to be, and how do I get there? Well, if we're looking at the first one, 53 times 53, grabbing a calculator, comes to 2,809. All right. What we can do is somehow find perfectly squared numbers that would actually get there. We could jump into hypothetical situations, like let's say I start with 20 squared, for example, which is, or 30 squared. 20 squared, remember, is 400. 30 squared is 900. 40 squared is 1,600. 50 squared is going to be 2,500. So I've got to get to 2,800. It looks like it could be anywhere between this range over here, right, at the moment. So how do we actually find this range? What we have to do is, so we're going to take numbers in between here, maybe from 41, and we could use trial and error, and then maybe get it from there. Is there any relationship between the numbers? Is there any relationship between 3 and 4? It's 3 plus 1. This is 5 plus 7. Is there a possibility of forming a relationship between A and B such that that? So that's not really something. So if we have to complete this one, what we end up with is, what if we had 28 and 45? All right, so 28 squared after trial and error comes to 784, and 45 squared after trial and error comes to 2,025. And 2,025 plus 784 comes to 2,809. So this one would be what we're looking for there. So this number would be 28, and this number would be 45. The next one, what two-digit number reverts to itself if you add the digits and multiply by 3? So 227 goes 2 plus 7 equals 9, right? And if you multiply the digits, if you add the digits and multiply by 3, so we add the digits and then we multiply by 3, it goes back to 27. So 27. A3 is that dimensions, write the area in meters squared. So we have to convert this into meters. So this is 1,000, so 0.297 times 0.420. All right, 0.297 times 0.420. That's going to be 0.124 or 125. 0.125 meters squared. What are the last two digits of 7 to the power of 2019? Well, what we have to think about is 7 to the power of 1 is 7, 7 to the power of 2 is 49. What's 7 to the power of 3? 7 to the power of 3 is 343. And is there a pattern to these last digits? Let's check 7 to the power of 4. That'll come to 2401. And 7 to the power of 5 will come to 16807. 16807. And then 7 to the power of 6 should repeat itself. 117649. 117649. So you can see it's 7931, 7931. So what are the last two digits if it's to the power of 2019? Well, from 1 all the way until 5, until 4 actually, 1 to 4, it repeats itself, right? So 1, 2, 3, 4 is a repetition. So then if I can look at multiples of 4, so for example, this is going to be 7 to the power of 7, 7 to the power of 8 is going to be, again, 1, right? So it's 7931, you can see 7931, it's repeating itself. So 2019, can that divide, what's 2018 divided by 4? Not a nice number. What about 2016 divided by 4? 2016 divided by 4 is 504. So this is equal to 7 to the power of 2016 times 7 to the power of 3, right? This over here is going to be a multiple of 4, right? Which means that this number over here is going to end over there, which means this is going to be the next 3. So it's going to be 1, 2, 3. So it should end in the digit 3. All right, what are the last two digits? 3. And will it be 3 and 4? By the looks of it, maybe 3 and 4, because this is going to be 4 and 9. All right, and that's more or less, we just ran out of time. But yeah, so just to quickly stop there, quickly double check, do you agree? Do you think that's the answer? Do you think the answer would be um, for question number 17? Do you think the answer would be 43 maybe? Or do you think it would be something else? The last two digits of 7 to the power of 2019. What will that be? All right, last one. So 43. Okay, we'll stick with 43. Thank you guys. Thank you so much.